Kia ora. Today's video tutorial is about mass calculations, also known as yield calculations. So today we're looking at sodium metal reacting with chlorine gas to give us sodium chloride or table salt, NaCl. Now the problem we're working with today is this one: calculate the mass of sodium chloride that forms when 2 grams of sodium reacts with excess chlorine gas. Now, excess for chlorine means that there's plenty of chlorine there, so all of the 2 grams of sodium will react to form sodium chloride. And before we can go much further, we need a balanced equation. Now, a balanced equation is provided for you here, and we can see that 2 moles of sodium reacts with 1 mole of chlorine to give us 2 moles of sodium chloride. So we have a ratio that's been given to us for the sodium and the sodium chloride. Not too interested in the chlorine here. That's not part of the calculation that we're going to be carrying out today, so we can just ignore the chlorine for now. Now, in our table, we need to put up some headings: sodium and sodium chloride. So it doesn't matter which column the sodium and sodium chloride go, but we'll put them in our table, which we're going to use as a sort of graphic organizer to help us organize our thoughts. So we'll put in here the information that we know from the balanced equation and from the question, and we'll be able to work out what steps we need to carry out in our calculation and what order to do them in. So what do these stand for? So R is for ratio. And the ratio we find from the balanced equation. In this case, we're interested in sodium and sodium chloride. We see it's a 2:2 ratio, but let's simplify that so we've got a 1:1 ratio. N. What does N stand for? N is the amount, okay, which we measure in moles. And that comes from the formula N equals mass over molar mass, or amount equals mass over molar mass. N equals little m over big M, where the little m is mass in grams and the big M, capital M, is the molar mass in grams per mole. Now from the problem we've been given, we know what mass of sodium we have, so we pop that in our table. There you go, 2 grams of sodium is reacting. Make sure you put it in the right column. Now that's all the information the problem tells us, but we can work out the molar masses from the periodic table. And you'll always be provided with a periodic table, so you're always going to have that there to help you. So we're interested in sodium, which has an average mass on the periodic table of 23. And the other element we're interested in is chlorine, and sodium chloride, and that has a molar mass, or an average mass rather, of 35.5. So if we go back to our table, the molar mass of sodium was 23, and the chlorine plus the sodium, 23 plus 35.5, gives us a molar mass for sodium chloride of 58.5. Now you can see in the sodium column that we have just one gap, so we have enough information now to calculate the amount of sodium present. So that's going to be the first step in our calculation. Then we can use the ratio that we've worked out from the balanced equation to work out the number of moles, or the amount of sodium chloride that's present in this reaction, or formed actually in this reaction. And then we have enough information to work out the mass, which is what we're asked to do in the question: work out the mass of the sodium chloride that forms. So there are our steps for our calculation. So if we just move on to the next page and take that information with us, we can see how we might step out our calculation. So the first thing we want to do is work out the amount, or number of moles, of sodium. So we write that down with the formula first. The amount of sodium, notice I put Na in brackets after the small n, just to say, well, actually this is the amount that we're calculating. It's the amount of sodium, and that equals its mass over molar mass. Okay, our mass is 2 grams and molar mass 23 grams, so we substitute in those numbers and then we can solve it. And that gives us an answer that, when rounded to 3 significant figures, is 0.0870 moles. But you'll have a longer number in your calculator, and you should leave it there. Let's not round until the very final step, so we'll leave that number in your calculator. Now, next step, step 2, we use the ratio to work out the amount of sodium chloride. So that will look like a 1-to-1 ratio, or is a 1-to-1 ratio, and that will look like N NaCl, which is what we're trying to calculate, equals N of Na. Now we already know that number because we've just calculated it, and that was 0.0870 moles as well. Now we have enough information to calculate the mass of sodium chloride. That's our step 3, and mass equals amount times molar mass, and I've got sodium chloride after the little m in brackets to show that I'm calculating the mass of sodium chloride here, and we've got amount 0.0870 times the molar mass 58.5, and that gives us a number of 5.09 grams, and that's been rounded to 3 significant figures. Now if you take the number that was in your calculator from step 1, multiply it by 58.5, you'll have a much bigger number, or longer number, not bigger number, longer number than 5.09, but you need to round it appropriately, and in this case all the data given to us is in 3 significant figures, so our answer also needs to be in 3 significant figures, and that's why we round to 5.09 grams. So that's how you calculate mass, or mass from another mass. Thank you for watching today's video.